This is the poster for the stateful DBA hypervisor supporting SLAs with low latency and high availability in shared ponds. The authors are Frank Sline, Samuel Zepp, and Marco Ruffini of the Connect Centre, Trinity College, Dublin, Ireland, OFC 2021. Our interests are specifically in relation to the disaggregation of ponds. Ponds are an efficient means of distributing fibre broadband services. There has been much activity in the core project on the disaggregation of the telco central office, where commodity white box components are used in the virtualization of network functions at the edge data centers. We investigate an SLA-oriented hypervisor, which is applied to the virtual DBA function of a PON. This makes the PON useful for latency-critical applications such as LTE, in particular for recent advances in the cooperative transport interface. Our SLA hypervisor uses a stateful mechanism that can make prioritization decisions based upon the history of grant allocations at a flow level. The scope of our hypervisor is to minimize the likelihood of breaching any SLA associated with different services from multiple VNOs. In this poster, we show an SLA hypervisor architecture, the algorithm, and we demonstrate a scenario that spans multiple VNOs, SLAs, and grant allocation sizes. When compared with the stateless approach, our stateful approach respects all SLAs fairly in terms of packet loss and latency. The implementation of an SLA-oriented DBA hypervisor requires a stateful mechanism that can make prioritization decisions based upon the history of grant allocations at a flow level. This enables the hypervisor to track how closely a given flow is to breaching its SLA and to prioritize grant scheduling accordingly. The scope of our hypervisor is to minimize the likelihood of breaching any of the SLAs associated with different services from multiple VNOs. Our system stores SLA parameters indicating the latency threshold in microseconds and the target percentage of grants before breaching the SLA. The hypervisor keeps a flow table recording the VNO ID J, the flow ID I, the number of grants allocated for which threshold was exceeded C, the SLA identifier S, and the total allocations count P. Our algorithm uses a cost function to schedule the allocations within the next physical frame. Such a cost function is proportional to the likelihood of breaching a flow SLA. The algorithm assesses the latest time at which allocations across all virtual bandwidth maps can be scheduled to keep within the bounds of their SLA. It calculates an initial estimate of the cost of placing the allocations, considering the time associated by the originating VDBAs in the virtual bandwidth map. It resolves collisions by scheduling allocations with the lowest cost sooner and moves instead higher cost allocations, thereby avoiding breaches of SLAs that are close to their availability limit. In the event that an allocation is scheduled to time that exceeds its SLA threshold, the algorithm updates the counter for that flow. The validator approach will consider a scenario with two VNOs sharing a PON. Each VNO is allocated 50% of the upstream capacity. Both VNOs use their VDBAs to fill their bandwidth maps independently. We vary traffic that is SLA oriented between 10 and 90% of the total. Two SLAs are defined. SLA 1 has a target latency of 25 microseconds for 95% of the grant allocations. SLA 2 is 12.5 microseconds for 90% of the grant allocations. Three different average sizes of grants are considered: 10, 35, and 70 units, where a unit is 0.11 microsecond on an XGS PON. We see that almost all allocation types meet SLAs up to 60% of the SLA-oriented traffic offered, after which availability starts dropping significantly. We also see that latency performances are similar with respect to grant size, with larger grants suffering slightly increase in latency. We compare our stateful approach against a stateless algorithm where SLAs are associated with different priority levels. You see that our stateful approach treats all SLAs fairly, while the stateless approach prioritizes one SLA over another. Also, the stateful approach has consistent latency, while the stateless approach does not respect latency requirements. Notice that SLA compliance cannot be controlled adequately, and generally SLA 1 availability is maintained at the expense of SLA 2 flows, which are totally unable to meet their SLA. Overall, the key advantage of our SLA-oriented DBA hypervisor is that both SLA services are equally maintained independently of their latency and availability requirements.